Okay, all four of these are in the formula booklet. Most likely scenario is that you'll just have to differentiate them, and you can use the formula booklet to just say tan x differentiates to sec squared x. In the instance that you have to show these things, and I checked the spec and it is in the spec, you have to do it in a certain way. So the way you would show that tan x differentiates to sec squared x is by you expressing tan x as sine over cos and applying the quotient rule. And it's a little bit of trig work as well, like simplifying identities, but you can hopefully see that it does get to sec squared x. For the other three, cosec x, sec x and cot x, we are using the chain rule. So I'll do this one, I'll explain it in detail, and then the rest it should kind of follow. So cosec is 1 over sine x. Sine x, 1 over sine x in index form can be written sine x to the minus 1. To differentiate, we would apply, if you were using the chain rule, so we might say u equals sine x and do it that way if we're still rusty with the chain rule. But to be honest, the amount of practice you should have done from the homework and what have you, we were thinking about the chain rule now as we've got a function inside, so I'll multiply the function inside by the coefficient, so we've got this minus 1 lots of the function inside to the power of minus 2, so the power drops, and then it's always times by the derivative of the function inside, so in here it's inside we have sine x, so we times by cos x. Then it's about manipulating that and simplifying that basically. So starting off by putting this back as a fraction, we'll have minus 1 over sine squared x, and so that would go to minus cos x over sine squared x. And doing this thing here where we separate the fraction is quite a common thing that you have to do that's going to help you simplify things. So if we consider that cos x could be, say, cos x times 1 and sine squared x as sine x times sine x, the way that multiplying fractions work means that we can consider them individually. So we've got a cos x and a sine x, so that would be a cot, and 1 over sine is cosec, and we still have the minus here, so it goes to minus cot x cosec x. That has been done here again, and it's at this stage where we start thinking about breaking it up. Be careful with the signs and all that business, but we just express we begin by expressing each of them as cos x to the minus 1, sine x to the minus 1, tan x to the minus 1, and applying the chain rule, and then with a little bit of fiddling around with the identities, you can simplify it to its to the form that it takes in the formula booklet. As I say, it is in the spec. It's probably unlikely you'd get asked to show this, but you'd just be expected to do the differentiation. But yeah, it's worth knowing anyway. There was questions like this at the end of the exercise 31 in the homework, so when I sent you the answers to those, I think I sent everybody an individual email. There you can sort of check that work. All right.